In this video, we're going to look at quadratic equations. What I have done is listed 4 topics within quadratic equations that you should be able to do. First, we're going to look at factorising, which is approximately a grade 5. Secondly, we're going to look at solving by factorising, which is roughly a grade 5 to grade 7, depending on the quadratic. Thirdly, solving by quadratic formula, and again that's between grade 5 and 7. And lastly, solving by completing the square. Now this is anywhere from grade 8 to grade 9. Moving on to the next page, we're going to look at factorising first. So here I've got 3 questions which I'm going to do by factorising, or attempt to do, and providing you watch this entire video, you'll kind of find out why each topic within quadratic equations exists, and hopefully this video will kind of be an all-rounder visit and kind of clear everything up for you. So when we see factorising, we need to think about putting into brackets, and this stems all the way from something as simple as 3x plus 6xy. If you're given that expression and you're asked to factorise it, you pull the highest common factors out. So we start with the numbers. The highest common factor you could pull out is a 3. If we look at the letters, so we've got x and then we've got y as well. So we can only pull out the x. So if we pull out 3x like that, we open a bracket. Now you ask yourself, how do you get 3x? That would be 1, because 3x times 1 will give you 3x. And then how would you get plus 6xy? Well, we've got 3x on the outside, and we need to first multiply the number, and secondly we need to get the y. So to get the number, it's going to be 2, because 3 times 2 will give us 6. We've got an x there, so at the moment if we left it like that, we'd get 6x, but we need 6xy, so I need to put a y here and then close that bracket. So when you see factorising, think about putting it into brackets, and then we can go from there. So looking at the quadratic that we've got here, we have x squared minus 4x minus 45. So what I'm going to do is I'm going to call this ax squared plus bx plus c. Now that's the standard template, if you like, for a quadratic. Now this technique that I'm going to use to factor this is where we multiply a times c. So if we look at that quadratic, a, it's not there, so that means it's 1, okay, and c is minus 45. So if I do that, a times c, I get the number 45. Okay, it is negative 45, but that doesn't matter, so let's just keep it as 45. Now what I need to do is I need to find all of the factors of 45, and when I do find those factors, I need to find 2 numbers that either add or subtract to give me this negative 4x, and this negative will matter. So if we start off, of course, we've got 1 times 45, and then we work our way through. So we can do 5 times 9, and you can just stop there immediately if you think the numbers that you see could potentially make the negative 4x. Now the reason I say that is because there are times when you think the numbers will work and they don't. Okay, so should that happen, you just need to continue with the factors and working until it does. Now at GCSE level, you're not going to be given or asked to factorise a quadratic that cannot be factored, so you don't need to worry about certain other techniques and how to check and so on. But let's just forget that for now and just focus on factorising this question. So immediately I can see 5 and 9 could make 4, or a negative 4x, so I'm going to stop there. Now what I'm going to do is I'm going to rewrite the quadratic, so x squared minus 4x minus 45. Now the numbers that I'm going to use are 5 and 9, and then I'm going to split that. So what do I need to do with 5 and 9 to give me negative 4? Well, if I start with negative 9 and I add 5 to it, it's going to give me negative 4. So I'm going to write the original x squared, which you can see there, but instead of negative 4x now, I'm going to split this to negative 9x and plus 5x. And then I'm going to write the negative 45 that was already there. Now once I've split this, so remember I've split this into these two here, I'm going to draw a line down the center. Now I'm going to imagine, I'm going to focus on the left hand side, I'm going to imagine that the right hand side doesn't exist. So how can I factor x squared minus 9x? Well, I pull the x out. There are no numbers, so that's where I can stop. And then I open the bracket, x minus 9, and close the bracket. Now what I need to do is whatever I have in this bracket here, I need to just copy it straight over. Okay. Now I need to find a number here that when multiplied here will give me above. So I need to find a number that will give me 5x. So if I try a positive 5, let's try this. Positive 5 times x gives me positive 5x. Positive 5 times minus 9 will give me the negative 45, so that works. So the last part, I need to combine the green section. Okay, so this is going to be x plus 5. Put that into a bracket. And then I just need to copy down the bracket that we got in the first place, which is the x minus 9. So we've now factored that quadratic equation. Okay, and you can always check because we can use FOIL. So if I just write x plus 5, x minus 9, if we do the firsts, we end up with x squared outside minus 9x inside plus 5x, and then last negative 45. If I now simplify this, I get x squared minus 9 plus 5 will give me negative 4x minus 45. And this answer at the bottom is exactly what we started with up here. So having done question 1, I'm now going to move on to question 2. So we've got this quadratic x squared plus 9x plus 20. What do we need to do? Well, first of all, we need to remember that it's ax squared plus bx plus c. We then need to multiply a and c, so a times c. Okay, so that's again 1 times 20, but I'm not going to write it. So 1 times 20 is 20. Underline it and then list the factors. So I've got 1 times 20, of course, 2 times 10, 4 times 5, and again I can see that this pair here will potentially work for the positive 9x. So writing down the equation, x squared plus 9x plus 20, and remember when we're factorising, we do not set it equal to 0. Okay, that's solving, which is next. So we've got x squared plus 9x plus 20, and now we've got potential solution to factoring with the 4 and the 5. So if I now write x squared, I need to think of what combination of positive and negative is going to give me the positive 9x. Well, that's going to be plus 5x plus 4x. Now it doesn't matter what order you do it in, as long as it's there. Now if I split the line down the center and then factor the left hand side and then the right. So to factor the left hand side, x squared plus 5x, I'm going to pull the x out, open up a bracket, x plus 5. Whatever I get in this bracket here, I immediately copy over. Then I need to think of this number here that will multiply to give me this above. Okay, so let's just say we try positive 4. Let's try this. Positive 4 times x gives me positive 4x. Positive 4 times positive 5 will give me the plus 20, so that worked. So now if I write this part and this part in a bracket, I get x plus 4. And then I copy over the bracket that I had initially, so I'll get x plus 5. Now I can always check, it's a good idea. X plus 4, x plus 5, do our FOIL, so we get x squared plus 5x plus 4x plus 20. Simplifying it, we get x squared plus 9x plus 20. Does that meet the question that we started off with? Yes, it does. Now if we move on to question 3, which is our last question for factorising. So again, ax squared plus bx plus c, and if you write that enough you will remember it. We need to be able to, or attempt to factor this, so let's go. So a times c, well that's 1 times 14. Again, don't really write it because you're just making extra work for yourself, but just write down what the answer is. Just be very careful if this was 2x squared. Okay, make sure you actually remember to do the 2 or 3 or 4, wherever it may be. So a times c, that's going to give us 14. Same technique, list the factors. So 1 times 14, 2 times 7, and that's all we can do. So if you're looking at these numbers here, we need to somehow make positive 4x. So look at the combinations, try them with positive and negative, but if we're looking at this now, we cannot make plus 4x, because we've got plus 7 take away 2, that's going to give us plus 5x. Even if we had negative 2 plus 7, that still doesn't work. So this does not factor. Okay, like I said, in the exam, you will not be given a question like this and they will say factorize. They will tell you to use another technique. So that's what we're going to move on to next. Okay, so now we're going to move on to solving by factorising. So just to speed things up, I'm going to use the answer that we just previously got because they're exactly the same questions. So my factors should be factorised. Factorised was x plus 5, x minus 9. For the second one, we had x plus 4, x plus 5. And this dot factor. Okay, so if we're looking at what we've got here, obviously if this was in the exam, you'd be expected to do the previous step that we've just done, so where you had to factor, and then you'd have to do this step on top. So I'm just continuing that. Now, you might remember just a minute ago I said about setting it equal to 0. When you're factoring, you do not set it equal to 0, but when you're solving, you set a quadratic equal to 0. So bearing that in mind, if we follow through the whole process, and copying this down, we'll have a situation where we have the factorized pair of brackets equaling 0. So this last step, what we need to do is just set each bracket equal to 0. So basically we're splitting them up. So x plus 5 equals 0 and x minus 9 equals 0. So now if we do our algebra, we need to get x by itself. So I need to get rid of this positive 5. Well, in order to get rid of that, I take away 5 from both sides. So I end up with x equals minus 5. And that's one solution. And then same here, I need to get rid of this negative 9. So I'm going to add 9 to both sides. So then I end up with x equals 9. So our two solutions for that particular quadratic equation is minus 5 and positive 9. And they are where the quadratic would cross on the x-axis. We'll get more into that when I do a video on graphing of quadratic equations. Okay, moving on to question 2. We've got x plus 4 and x plus 5. Again, when we're solving, set equal to 0. We need to split x plus 4 equal to 0. X plus 5 equal to 0. So then again, get rid of the positive 4, we take that away. So we have x equals negative 4. Then we've got x plus 5, so we take that away to give us negative 5. So our two solutions are x minus 4 and x equals negative 5. Now for question 3, well, it didn't factor, so we are unable to find the solution to this quadratic via factorising. So in this case, we just have to leave it. Okay, solving by quadratic formula. So this is one of those formulas that you should know, and I'm hoping that most of you know it by now if you're taking these exams in June on May, June 2017, which is what I'm making this video for. But if you're watching this in the future, this is one of those equations that you must know. So it's a fairly long equation. Okay, I'll just write it in the top right hand corner now. So it's minus b plus or minus the root of b squared minus 4ac all over 2a. Okay, and that's the quadratic formula. So it's one of those equations that is spoken a lot about, and if you're learning this initially, it can seem a bit daunting, but by the time you're in year 10, year 11, definitely by year 11, you should kind of know it off by heart. So let's look at question 1. Again, I said all the 3 questions are the same, but let's look at question 1, and the same as in what I've done previously. Let's look at question 1 and see what we can do. So from the previous questions, you'll notice I've been writing ax squared plus bx plus c. Now that is the general template of a standard quadratic. Of course it can be negative, like you see here, but that's just the general template. What we're interested in is a, b, and c. So what we need to do is we need to look at our template and compare that with our quadratic. So a, it looks like there is nothing there. When there is nothing there, that means it's a 1. So a is positive 1, and you'd know if it was negative because it would have negative x squared. But a is positive 1. Now we look at b. b is negative 4. Not 4, it's negative 4. Remember, always look to the left of a number and see whether it's a positive or a negative. So b is negative 4, and c is negative 45. Once we have a, b, and c, and you've remembered the quadratic equation, it's a matter of just substituting the values in. So I'm going to just try and fit this in here. So we've got minus b, so minus, open bracket, whatever the value of b is, it's negative 4. Then we've got plus and minus, so this is where some people get a bit confused. We've got 2 versions that are occurring, 1 plus and 1 minus. So I'm going to do the plus one first. So plus the root of whatever b is, so negative 4 squared, minus 4 times a, 1 times c, all over 2a. Now please, what I want you to do, no matter how easy you think it is, so say for example this bottom section here, well you could be thinking, oh, 2 times 1 is just 2. Okay, I would strongly suggest that whatever you do, make sure you just substitute the values in as you see them and let the calculator do its work. Okay, you could in theory be asked to do this without a calculator if the numbers are kind of easy enough to do. But please don't try any shortcuts at this stage. You don't want to lose any marks when you kind of hopefully know how to do this, so don't get too confident. So that's 1. So if you put all of that into a calculator, you'll get your solution as 9. And for the other solution, I'll do it in a different colour. Negative 4 minus this time square root minus 4 squared minus 4 1 minus 45 all over 2 times 1. Put all of that into a calculator and you'll get negative 5 as your solution. Okay, now the only differences between these two is this here and this here. So if you compare that to what we got from our solving by factorising previously, you'll see that the answers are exactly the same. So sometimes it's a case of it's a different way of doing it. Sometimes the quadratic doesn't factorise, so you have no choice but to use the quadratic formula. So generally for GCSE, you won't be asked to factorise something that cannot be factored. But if you do that technique of factorising and it's not stated and you can't find the numbers working, and it doesn't mention to use the formula, then use the formula, providing it's a calculator paper. And even if it's not a calculator paper, and the question's kind of being really harsh, you can still follow it through, providing you write absolutely everything out, and you can find your two solutions. Okay, so if the factorising technique doesn't work and it doesn't factorise, then you can use the quadratic formula as we did here. Obviously, it's only useful if you actually remember it, which is why it's so important to try and remember this formula as best you can and know it off top of your head by the time the exam comes. Right, if we get on to question 2 now, same kind of thing. We've got ax squared plus bx plus c. Scan the quadratic you've got, a, b and c. A is 1, so let me just write in a different colour. A is 1, or positive 1, b is positive 9, and c is positive 20. So we know the quadratic formula now, so I'm going to do the positive one first again. So we've got minus, open bracket, b. You can write the positive 9 in there if you want. It's completely up to you. It's the negatives that you really need to be careful about. So we're going to do the plus square root 9 squared minus 4 times 1 times 20 all over 2 times 1. Okay, now if you're doing this quadratic equation or quadratic formula in general, and you get something along the lines of math error, just check your symbols. A lot of the time it's to do with this here, and you're trying to take the square root of a negative, which cannot be done, or at least for GCSE. So if you put all of that into your calculator, you get a value of x equals -4. And we do the same thing again, but this time for the negative. So and then you'll get a answer of -5. And again, if you compare that with what we got previously, you get exactly the same answer. Okay, again, like I said, it's just a different technique. Now, if we look at question 3, we couldn't get any solutions by factorising because the quadratic equation didn't factor. And this is where the quadratic formula comes in. Okay, so if a quadratic equation does not factor, you have to use the quadratic formula. You could also use complete square, which I'll show you later on. So let's look at this. We've got, again, ax squared plus bx plus c. Scan what we have. So we have a, b, and c. And I would encourage this technique all of the time. So set out what a is, what b is, what c is. Make it nice and clear, that way you won't make any mistakes. A is positive 1, b is positive 4, and c is -12. So once we know that, we know what the quadratic formula is, we can then substitute minus b, which is positive 4, plus the root of 4 squared, take away 4 times 1 times c, all over 2 times 1. So if you do that in your calculator, you end up getting an answer of 2. So one solution is 2. Now we'll do the same thing, but changing the positive to a negative. Again, you'll be expected to write all of this out, so no shortcuts. So -4, negative times positive 4, I should say. Square root, so take away the square root of 4 squared minus 4 times 1 times -12 all over 2a, which is 1. If you do that in your calculator, you end up with an answer of -6. So this quadratic we couldn't factorise, but we can still solve. So we've got a solution of x equals 2 and x equals 6. And again, the solutions are where it crosses on the x-axis. And there are times when there are no solutions. But let's just stick with this for now. Okay, and now we're going to look at how to solve by completing the square. So as it says here, this is a grade 8 to grade 9 topic. So if we look at question 1, we've got x squared minus 4x minus 45. And now we need to solve, which is find the solution. But this time by completing the square. So if we look at this, we've got x squared minus 4x minus 45 equals 0. Now in order to complete the square, what I need to do is I need to write x squared minus 4x. I then need to leave a gap, write the equals sign, and I need to shift that negative 45 over to the right hand side. So if it's a negative 45 at the moment, it's going to become a positive 45. And also need to leave space for another gap. Now this gap here is what's known as the magic number. So you always add the magic number. So the magic number is as follows. It's half of b. Okay, so b over 2, and then you square it. So in this case, if b is negative 4, negative 4, half of that, what is that? That's negative 2. Negative 2 squared is 4. So our magic number is 4. So we add that to both sides. Now, what we see here on the left hand side is a quadratic that we can now factorise. So we can do that like we did with our standard technique. So what I'm going to do is I'm going to ignore the right hand side now where the equals is. Ignore that. I'm going to treat it as if I've got a quadratic, which is x squared minus 4x plus 4. So if you remember the AC rule, 1 times 4 is 4. So we've got 4. We need to list the factors of 4. 1 times 4 and 2 times 2. We need to make negative 4. That will mean we go with minus 2 and minus 2. So if I now write x squared minus 2x plus 4, I end up with this. I split it down the centre. I then factor the left hand side, which happens to be x open bracket x minus 2. Copy that over and then find the number that goes here. Well, if we try negative 2 times x gives us negative 2x. Negative 2 times negative 2 will give us the positive 4. So if we copy the brackets down, we'll end up with x minus 2 and x minus 2. Now we can simplify that to make it x minus 2 squared. Now if I copy down this entire section, bring it down here, I've got equals 45 plus 4 will give me 49. So now I have this quadratic in a complete square form. Okay, I can put it in vertex form, which is where I do x minus 2 squared minus 49 equals 0. But I'm being asked to solve. So this is vertex form here. Okay, and that show you the turning point on a quadratic graph. So if I just get rid of that for now. Okay, now this technique that I showed here is a longer way of doing it. There is a shortcut. Okay, I prefer doing it in this way because then it's a lot easier to remember how to do. But the shortcut is as follows. When you're at this stage, here, you've got the left hand side. Once you've got that left hand side with the two magic numbers, you can just open up a bracket, write x plus, and then you do half of b, but you don't square it. Okay, so half of b, so it's negative 4, so that will be negative 2, and then close the bracket and square it. So you don't actually square it, so if we simplify this, you end up with x, a plus and a minus make a minus, so x minus 2 squared. And you can see that this here matches exactly what this here is. Okay, so it saves us writing out all of that AC, but that's kind of involving step 1 with a complete the square technique. So I'll let you choose, or you can choose how you'd like to do it, either shortcut technique or a slightly longer approach. It's completely up to you. So if I just get rid of this for now, we still haven't solved, because remember, solved means to find a value or values for x. So let's imagine you're given this as your equation to solve, and we can go from there. So how do I get x by itself? Well, I need to get x equals. So what I can do here is get rid of this power that I see. So the inverse of that will be to square root it. So if I square root, I'm going to end up with x minus 2 equals the square root, and remember it's plus or minus 49. And then I've got the negative 2 that I need to deal with. So then I'm going to end up with x equals 2. One solution will be plus the root of 49, and one solution will be to minus the root of 49. So then if we work that out, that's x equals 2 plus square root of 49 will be 7, and x equals 2 minus square root of 49, which is 7 again. Then we've got x equals 2 plus 7, which will give us 9, and x equals 2, take away 7, which will give us negative 5. And again, if you look to the previous stages, so step 2 and 3, you'll see that you get exactly the same solutions. It's just a different way of doing it. So hopefully that wasn't too kind of quick. I'm going to go through question 2 and 3. So maybe what you could do now is pause it and give it a go yourself, or you can carry on watching the video. So with question 2, we've got x squared plus 9x plus 20 equals 0. We need to shift the c, which is the 20 in this case. So that's going to make it, let's do it in x squared plus 9x equals, and then our negative 20 now, because it's shifted to the right hand side, our marks, or our magic number position, we add the magic number. Okay, now the magic number again, we're going to have to half it and then square it. So this is where it comes slightly more difficult, and the only reason for that is because of the involvement with fractions. So if you're good with your fractions, you won't find this too difficult, but this is kind of what makes it, or starts to make it, a grade 8, grade 9 topic. So if we look at the magic number, it is 9. Half of 9 is 4.5, and then we need to do 4.5 squared. So I'm just going to write that to make it clear. Magic number. So we've got 9 over 2 all squared. That's the operation we do. Now we don't want to write 4.5 squared. We want to keep it as fractions. So if I do this in terms of fractions, I'm going to have 9 squared, which is 81, and 2 squared, which is 4. And that is, of course, 4.5 squared, or the answer to it. So now I've got x squared plus 9x plus 81 over 4 equals minus 20 plus 81 over 4. Right, now this part you can still do a times c, but it's going to be a bit difficult to get the factors of that. So what we can do is we can now implement the shortcut. So there are two ways which you can do this. You can either do the longer technique, which may take you just too long, and to be honest with you, it's not worthwhile, but it's important to know why that comes about, and it shows better understanding. So if we go with the shorter technique here, which I showed previously, you open up a bracket, x plus, and then you do half of the b. So that happens to be 9 over 2. Close the bracket and square it. So that gets us to the stage where we've completed the left hand side. we now have to do the right hand side. So we have minus 20 over 1 plus 81 over 4. So if we make both those denominators the same, so in this case keep it as 4, what do we have to do to 1 to get to 4? Times it by 4. So 4 times negative 20 will be minus 80, plus 81 would stay the same. So then that would work out to be x plus 9 over 2 squared equals 1 over 4. So now we need to find the solutions to get x by itself. So if we look at this, we're going to end up with x plus 9 over 2 equals the square root of a quarter. And then we need to deal with the 9 over 2, so take that away. So x equals minus 9 over 2. And then of course this is plus or minus, so this would be plus the root of a quarter. And our other solution, which we could write up here, would be x equals minus 9 over 2 minus a root of a quarter. So if we put that into our calculators, we get x equals negative 4. And for the other one, we end up with x equals negative 5. Okay, so exactly the same answers as previously. Again, just this is complete the square. Okay, I'm finishing off on question 3, where we have x squared plus 4x minus 12. So right now, leaving enough space for the magic number, we've got x squared plus 4x, and then we've shifted the negative 12 to the right hand side, so it becomes positive 12, and then of course space for the magic number. So magic number is half of b and square it, so half of 4 would be 2, and 2 squared is plus 4, so our magic number is plus 4 for both sides. So we can do it either way, the slightly longer way or the shortcut way. Let's try the shortcut way again. So that will be open the bracket, x, half of the magic number, so 4 divided by 2 is 2, so we've got a positive 2. Then squared equals 12 plus 4, we get as 16. So from this stage here, we can solve the equation. So to get rid of the square, we can square root it. So x plus 2 equals the square root of 16. Don't forget this is plus or minus. And then we've got two ways of going. So we have x equals, to get the positive 2 to the right hand side, it becomes negative. So negative 2 plus the square root of 16. And x equals negative 2 minus the square root of 16. So putting a line here, we end up with x equals minus 2 plus 4. That's the square root of 16. And x equals minus 2 minus 4. So x equals minus 2 plus 4, which is plus 2. And x equals minus 2 minus 4, which is negative 6. So hopefully that section of complete the squares kind of cleared it out for you a little bit. You can see you can do the shortcut technique or the slightly longer technique. One thing I would say is if it's like question 2, you start getting with fractions. The fraction part that's okay to deal with is this section here. Okay, but when you start getting fractions here, that makes it a bit more difficult, and I would strongly suggest the kind of shortcut technique to be able to deal with that. Now one last thing which I probably should have mentioned in the beginning is as follows. You may not necessarily get asked to complete the square of a quadratic, but it may say express in the form and then x plus a squared plus b. Now the letters are interchangeable. Sometimes it can be P, P and Q. Okay, and this is what you call vertex form. So I mentioned this briefly earlier. It's where the turning point of the quadratic. So vertex form is like this. So vertex form, for example, for question 3, at this stage here, rather than solving it, we would simply write, and I'll write this in blue, x plus 2 squared minus 16 equals 0. So that would be our vertex form, and then to solve, we need to do what we did, where you square root and then go from there. Okay, so you'll see it mentioned as expressed in the form. Could be x plus c plus d. You know, the letters are interchangeable, but that's the format that will kind of give you the hint that you need to complete the square. Okay, and just to finish this video off, here's an exam question with a bit of an applied quadratic rather than just here's a quadratic, solve or factorize it. So if we look at this question, it says this diagram shows a six-sided shape. All the corners are right angles. All the measurements are given in centimeters. So we've got this shape here, and it says the area of this shape is 85 centimeters squared. Show that 9x squared minus 17x minus 85 is equal to 0. So with these show that questions, they're showing you what the actual answer is. So it's our job to kind of get to that point. So first clue that we've got is it says that the area of the shape is 85 centimeters squared. So it kind of indicates that, okay, we're going to need to find the area of shape. Okay, now what we can do is we can split this up. I'm going to split it here. I'm going to call this shape 1 and shape 2. Now these are rectangles now. So for the area of shape 1, let's go with length times width. So A equals L times W. So A equals length. Doesn't matter which one you call it, as long as you don't duplicate. So I'm going to go with the length as 2x minus 7 and the width as 3x. So let me just put times here. Okay, then of course when you've got two brackets next to each other, it will be multiplication. So I'm just going to write 3x 2x minus 7. Now I can take that out of the bracket because it's just by itself. Then I can do my expansion here. So for A, for shape 1, sorry, I get 6x squared minus 21x. So that is for shape 1. I'm now going to do the exact same thing, but this time I'm going to do it for shape 2. So for shape 2, area equals length times width. Area equals 3x plus 4 times x. Okay, again, just to clear it out, I'm going to put x on the outside. 3x plus 4, and then expand like so. So x times 3x is going to give me 3x squared, and x times 4 will give me plus 4x, and that's for shape 2. So being a compound shape, or where I've split the shape into 2, in order to find the total area, I'm going to have to add shape 1 and shape 2's area. So a bit of algebra. So I'm going to have A equals, and it's going to be 6x squared minus 21x plus shape 2, 3x squared plus 4x. So if I collect my like terms, I'm then going to have 9x squared minus 17x. So you can see from this section here that it's already matching part of what we have. Now we need to finish this off. So if I go here, it does say that the area of the shape is 85 centimeters. So what I've done here is I've essentially made a formula for this shape, for the area. They're telling us that the area is 85. So if I substitute that in, I'm going to end up with 85 equals 9x squared minus 17x if I look at what I need to show, I can see that I just need to do a bit of manipulation. So I need to make the left hand side 0, right equals 9x squared minus 17x. I need to get that positive 85 over to the right hand side, so that's going to make it negative 85. Then you can of course rewrite this as 9x squared minus 17x minus 85 equals 0, and we are done for part A. Right, now for part B, it says solve 9x squared minus 17x minus 85 equals 0. So let's say, for example, you couldn't do all of the algebra, but you are able to solve a quadratic equation. You could still get marks from both B and C. So with B, we can do a couple of techniques. We could still potentially factorize. Now you could test that out by timesing. We could complete the square, but the easiest one to select, especially if it's a calculator paper, and even if it's not, the numbers could be made easy enough to do, but we could use the quadratic formula. So if we remember that we have ax squared plus bx plus c, okay, and let me just clarify, sometimes there is no right or wrong way in what you do, just certain techniques will be a lot quicker than others, okay, so but you can't always factor any quadratic, so really it's a case of you can either use the formula or complete the square, which are basically the same thing, but let's not go into that. So formula is the easiest one, generally speaking, to do. So if we list what A is, what B is, and what C is. So A, in this case, is 9, B, negative 17, and C, negative 85. All we need to be able to do now is two things. One, recall the formula, and two, substitute correctly with brackets. Okay, please don't forget the brackets. So if I write the formula quickly up here, minus b plus or minus the root of b squared minus 4ac all over 2a. So filling that in now, I'm going to go with minus b, so minus 17. Very easy to forget that minus. I don't want to keep saying it. Please remember to use brackets. This time I'm going to go with plus first, so square root, open bracket, minus 17 squared minus 4 times a, which is 9, times c, which is negative 85, all over 2a, which is 9. So that's going to give me one solution. Okay, and then second is going to be minus 17. This time it's the minus again, square root, minus 17 squared minus 4 times 9 times 85 all over 2 times 9, and then that's going to give me a solution here. So if you type that all into your calculator for the first one, for the plus, you should get 4.159474732. Now it does say give your answer to 3 significant figures. So here's the first significant figure, the 4, the second is the 1, the third is the 5. So underline that, draw an arrow, look at the number to the right. The number to the right is greater than 5, so we round up. So this is going to be x equals 4.16. Okay, and for the negative solution, or the subtract the square root, you should get an answer of minus 2.27058584, and then again rounding that to 3 significant figures. Third one here, look at the number to the right, and that will stay as negative 2.27. X equals minus 2.27, and that's the complete. So we've got two solutions here, one positive, one negative. If we look back at our shape, we've got for shape 2, there's just the height of x there, or width, depending on how you're looking at it. Now we can't have a negative width, could we? So that negative solution wouldn't be valid. So realistically, we're looking at the 4.16 as our solution. So x equals 4.16. Okay, and it says here, hence work out the length of the shortest side of the six-sided shape. So if we're looking at that shape, look for the shortest side. We can see that there is a side which is called 2x minus 7. So if we do that, 2 open bracket 4.16 minus 7, you get an answer of 1.32 centimeters as our shortest side. Now, in the exam, you can always, kind of go around the entire shape and just double check that. And I encourage you to do so, because sometimes in the exam, numbers like this will be there, but it could be, say, 3x take away 12 or something like that. So when you first look at the question, you might think, oh, it's not that one, it's obvious, it's this one. In the exam conditions, I would strongly recommend you just double check all what you can see to make sure that you definitely get that last mark, because you've done all the hard work. So don't give away a mark on the easy part. So that's quadratic equations. Hopefully you found this video useful.